So now we're going to have a look at this one first. So the system has 2 degrees of freedom, since each mass can be moved in the horizontal direction while the other is held still. Thus, two simultaneous equations of motion will be required to describe this system. Okay. The equations come from a free body diagram of each mass. Superposition is used to draw the free body diagram. So the force on M1 are due to, the first one is its own motion. Okay, you see this x1, it moves with x1 displacement, so these forces will have the x1 displacement. But on the other hand, we have to take into account the motion of m2 that transmitted m1 through the system. So this one, because it is shared with m2, so it got this a displacement of x2 as well. So x2 here as the impedances that shared with m1, and then you have this displacement x1 and the total forces for this one. So we have to draw all of this. You could see here the forces that connected to the object. You could see that's K1 for spring, there's damper Fv3, there's K2 of spring, and then there's a friction Fv1. And remember, the mass itself have its own acceleration, so we have to draw that one first. Okay, so let's draw the free body diagram. Okay, so you have that m1 here, m1. Okay, and then so all of this I will transform it into Laplace straight away. So this one is K1 displacement of x1s. So this is due to the spring. You also have the forces Fv1, which is this one that touches the floor. So you have Fv1 as that's an oval as okay, and then x1 s. Okay, and then the acceleration of m1, let's put it here, m1 s squared x1 s. Okay, so you could see this one, because it's pulling it the other way around, to the left direction, sorry. Okay, and then you also have the forces over here. Okay, so let's draw. There's the damper here, Fv3. So Fv3, I hope you understand my handwriting here. It's a bit awful, but hopefully you can bear with me. X1 as this is due to the motion of this is awful, sorry guys. Okay, draw S. Okay, and then there's the spring. You've got K2, X1 and S. Okay, so remember, this is just the force. You have to include the input, which is Ft. So let's put Ft. So ft, because I transform it into Laplace, so it's fs. Okay, so it's that direction with fs. So okay, so all of these are the forces, all of these are the forces on M1 due to only to motion of M1. Okay, so you could see that it's x1s, 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 and x1s, because it's only due to the motion of M1. So we have to include the motion for M2. Okay, I think we can see that. Okay, so we have to draw another one, which is M1, but due to the displacement of M2. Okay, still M1, but displacement of M2. So you got K2, the spring, K2, and then X2. And then there's another one is FV3, which is the damper S, and then you go S, and then X, 2, and then S. Okay, so these are the forces that are due to X2. Because of that, you could see that X1 and X2 displacement, but it's still M1. So what you have to do is use the summation. We are interested of the summation of this one. You can draw okay, you can draw the summation of those. I'm going to choose other colors so that you can see it. So let's say purple. Okay. And let's move it to the other side. Okay, so you got here okay, that's K1 plus K2 okay, X1 S, and then there's another one which is FV1 plus FV3 as you got S there, X1 S, and then there's also the forces that due to acceleration, M1, S squared, X1 S. Okay, and then remember that's also the input, but okay, let's just write all the forces K2, X2, and then there's S, and then there's another one here which is the damper, which is FV3 S X sorry, okay, X2 S. Okay, but remember you got that F as the input. Okay, so you got that F as input, which goes this way. So we put F as. So all of this, okay, guys. So all of this all the forces that we want to include in our equation of motion. This one is x2 due to x2, this one x2, x2, x1, 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 and this one as the input. Okay.